Okay, we're doing problem compound events part 2, second video. Okay, so here we're going to look for shaded regions that are described below. And Venn diagrams are really quite helpful to help organize our thoughts. And so what I'm going to do is I'm going to shade various things here. And I'm going to do the first one here, which is not A. That means everything that does not belong to A, I am going to shade here in pink. That's everything not A. Everything that is B, I'm going to shade in green. Okay, and so now it wants the union of these two things. So anywhere, that means anywhere it's shaded is where the answer is. And so if I consider that half moon there, it's everything all out here is what is shaded there. Okay, let's try this again. Another one. A. I'm going to shade in all of A, including this part in here. B. No, or not B rather, means I'm going to do in all of this, wherever it is not in B, so outside of the circle. And this intersection means where do they overlap? Well, they overlap in this region here. This is the overlap area here. So that is the shaded region. Continuing along, you should pause and try these ones on your own, both C and D, and then check your answers to see how you're doing. Not A means outside this circle. Not B. Oh, I messed up not A. Not A is also here. Ah, how about I get it right? Okay, so not A is everywhere not A. So that's, okay, so only this circle is open. Switching over to not B means, well, here's B. Everywhere that's from B's circle outwards is what I am shading. And so what I'm looking for is the union between the two. So basically anywhere there's a shade is the answer. So all this stuff that is in black, everything but that center sideways eye. For D, it's the same diagram, not A, but it's the region that's going to be different. So here is not A. Here is not B. Oh, not B is here. This is not B. And so what this problem here is saying, where do they overlap? Well, they overlap on the outside of these two circles. So here, nowhere is there overlap, so all outside here is where they overlap. Okay, another example. Group of 20 students, there are 12 girls and 8 boys. 2 of the boys and 3 of the girls wear red shirts. Make a table to illustrate this information. Well, if I'm going to make a table, I'm going to make something like this, and we will have boys and girls, and then there's a total. We'll have red shirts and not red shirts, and the total. Well, I know there's 20 in total. Now I start to plug in the information. There are 2 boys with red shirts and 3 girls with red shirts. So in total, there are 5 red shirt wearers. So that must mean there's a total of 15 not red shirt wearers. I do know that there's 12 girls and 8 boys. So 2 and plus something is 8. So this is 6, 3, plus something gives me 12. That must be 9. If I check this way, 6 plus 9 is 15. So here is my table for this information. Now B is saying, what's the probability chosen at random is either a boy or someone with a red shirt? So a boy or a red shirt. Well, this is the red shirt. These are the boys. So I am looking for this, and this scenario here, which is going to be 2 plus 3 plus 6 out of 20, which is 11 out of 20. I could also use our formula that says probability of B plus the probability of red minus the probability of the overlap. Because the probability of a boy is 8 out of 20. The probability of a red is a 5 out of 20. The overlap is this region here, 2 minus 2 out of 20, which again will give me 11 out of 20. So there's a second method to try it. For C part now, C, what's the probability a person is a red-shirted girl? Well, use good notation. What does this mean, red-shirted girl? Well, it means it's a girl and she has a red shirt. Well, that's this person, only this person, and it's 3 out of 20.